I'm Tree and welcome back to another video for the series. This problem is from 1984 AHSME. I think it stands for American High School Math Examination. So it was like exams before, I think, AMC. And it's problem 30, so it should be considered the hardest problem. And the reason why I chose this is because I just love the number 1984. It's one of my favorite books, so that's why I chose it. And like number 30, because why not? Yeah, so first, I think what we can do here is realize that, oh no, let's first write our 40 degrees into radians. So we know that 40 degrees is equal to, I will say 40 degrees over 180 degrees times pi. We should have like radian sign here like this, but by convention we know that this pi is not just pi but pi radian, so I will skip that. And this, the degrees cancel out and the zeros also cancel out, so you know that this is equal to 2 pi over 9. Now, so in other words, z is equal to cosine of 2 pi over 9 plus I sine 2 pi over 9. And everyone, I think, is quite evident that this is equal to pi over 9. Something is wrong with my pen, sorry, today. I think something's not syncing well. 2 pi over 9. So this, I think it tells that, yes, so yes, this is a root of unity of 9. So in other words, z to the power of 9 equals 1. Yes, so this is what we know so far. And now notice that this form right here is in the form of the sum of, I will say, k equals 1 through 9 k z to the power of k. So we can change this and notice that this is arithmetic geometric series. So let the sum equals z plus 2z squared plus dot 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 plus 9z to the power of 9. Now, if you had been studying for computational mathematics, I think one thing that is quite self-evident is multiply z on both sides. So we have 2z cubed plus 9z to the power of 10. Yes. And then what we are going to do is we are going to subtract. So we get s times 1 minus z is equal to z plus z squared plus z to the power of 9 minus 9 times z. And the reason why I wrote z here is because z to the power of 9 equals 1. Therefore, s is equal to z plus z squared plus plus z to the power of 9 minus 9z all over 1 minus z. Yes, now so we know that this thing is equal to this. I think we can simplify this thing more. And the reason why I think we can simplify this is because notice that z here is the root of unity of 1. So yes, I think we can use one thing. I think we can use Vieta here. Yes. Using Vieta is because if z is the root, then z squared is also the root of this. Like, so for x to the power of 9 equals 1, z squared z to the power of 9, they're all the roots, so we can think of it as like when we add all of them we get 0 by Vieta's formula. Or the other way to think about it is let's just vectorize it just in case this thing is not clear. So we get z minus 1 times z, wait, is it? Yes. Z to the 8 plus z, wait, is it right? 9, 8, 8, oh yes, it is right. Plus 1, right? Equals 0, but we know that z is not equal to 0, so this whole thing is equal to 0. Therefore, because if we multiply z to everything, we get this one. We get s equals negative 9z over 1 minus z. So this is what we know. So this is also what we need to, yeah. So if s is equal to negative 9z over 1 minus z, then we need to express minus z to the power of negative 1 in terms in the form of a sine b. Now notice that this is equal to 9z and we have 1 minus z here. We can flip them and then we can also split them. What should we do? Yes, so let's use this value. I think it's quite helpful. Oh, or maybe we can use this one, because if you use Pythagorean theorem, then we can compute the absolute values. So we get this equals, what is the absolute value of z? It is the distance from the origin and this thing, right? So it is, 1. Yes, it's simply 1. When we graph it, we get 1. And so we can say that this is 9. Then our numerator, it should be 1 minus z. Now we can compute 1 minus z. This is equal to square roots of 1 minus cosine 2 pi squared plus sine squared. Now this thing is simply equal to square roots of 2 times, no, 2 plus minus, sorry, 2 times cosine of 9 over 2 pi. Now one interesting thing that we can do here is this. And the reason why we can do this, or we decided to do this, is because we can notice that this is simply equal to sine of, it is pi, right? I think so. It should, yes, because it's half angle theorem. It's half angle, so we know that this is equal to that. So let's write this. Then we get the form that we wanted. 9 over pi, but pi is 108. The reason why we avoided radian here is because the problem gave us in degrees, so by convention let's use degree here. So I think this is the right answer. So yes, this is our final answer. I think the kick for this problem was noticing the arithmetic geometric series and then trying to use Vieta or anything from here, and noticing our half angle theorem here, half angle like formula or anything. Yes. So I think this problem is easier than other Olympiad problems. It was, I think, quite doable, and I really enjoyed this problem. And if you also enjoyed the problem, please don't forget to like and subscribe. If you also like this solution, and if you have better ideas or solutions or any comments, please feel free to leave them in the comment box below. Then thank you and see you tomorrow. Bye.